This video is going to be having a look at condensation polymers, and when we look at condensation polymers, they tend to ask similar questions to those in when you do addition polymers, in that they'll ask you to find the monomer from the polymer, and they'll ask you to find the polymer more likely from the monomer. So let's have a look at what creates condensation polymer. So first way is a polyester, and this is, as the word suggests, poly, many esters, so many ester bonds. And to make it, you need a carboxylic acid and you need an alcohol group. You'll make your polyester and you'll make your ester bond and you'll remove water. The other one is to make a polyamide, and this here is a polyamide bond. And to do that, you need a carboxylic acid group and an amine group. And again, condensation, so you'll remove the water. Now, how do we get these single bonds, these single types of bonds, to form polymers, so these repeating chains? And this is similar to how you'll make proteins and a lot of biological molecules as well. So in order for this to happen, your monomer must have two groups that can form this. All right, now this is probably the most basic example. So this is a polyester, so this is carboxylic acid and an alcohol, and they're on the same molecule. So if I take the same molecule and I put one there and I put one there, then what I will do is you can take the water off, and you're left with this continuous chain, and that's my polymer. All right, so that would be drawing. So when you draw it, you would have the curved brackets and an N like that. Now, if I go the other way, this is an amide group, so this is an amide bond, and there it is, there it is, there it is. Now, as a result, I've got a polymer chain, and I need to figure out where the monomer is. So what I'm going to do is I'm going to take that amide group, and I'm going to break it down the middle. And the same with the the ester group. I would break it down from the next to the carbon with double bond oxygen. So there's one, and there is another, which means that this here is my monomer. And I will just draw that like so. So there's my carboxylic acid, there's my R group, whatever that may be, and there's my amine. There is another way of doing one of these bonds or one of these polymers, and it's a little bit different, and it's quite tricky to spot when you first start doing this. So this is what we've looked at so far, is where you've got one monomer and you form a polymer chain. So the monomer must have a carboxylic acid and either an amine or a alcohol. However, you can do it where it's got carboxylic acid on the same molecule, and either two alcohol groups or two amines. So it's a dioic acid and a diol or a diamine. Now that means you have got two monomers to make a polymer. And as you've got two monomers to make a polymer, the repeating unit is one of each monomer. And the reason this will work is just for the same reasons before. You'll release water over here, and this one will release water over here, and you'll make a chain. It's difficult to spot, however. So what you would do to spot this is you're looking for this double bonded oxygen, because if the double bonded oxygen are inside of the other group that you're looking for, so in this case it's oxygen, for amines it's nitrogen. If they're on the inside, so it's oxygen, chained oxygen, double bond oxygen, chained oxygen. If that's the case, then you've got two monomers. If it is double bond oxygen, chained oxygen, double bond oxygen, chained oxygen, so they alternate, then you've got one monomer. Same with nitrogen. If it's nitrogen, oxygen, it's going to be one monomer, but in this case it'd be nitrogen, oxygen, nitrogen. So the two oxygens are together, therefore it's going to be 2. And you do exactly the same thing when you're trying to figure it out. You draw a line next to double bonded oxygen, because that's your carboxylic acid group, and then you can put your OH in to figure out where your carboxylic acid groups, and over here is your hydrogen. So if you're trying to figure out the monomers from the polymers, that's how you do it. Same thing, you just draw between, you just cut it between the double bond oxygen and the next molecule, and that should give you your monomers. As I said, if they're together, the double bonded oxygen are on the inside of the other group, then it's 2 monomers.